First of all, before I start, I would like to thank Walt for giving me the opportunity to present here. So this is basically the first time in the AGL event from our company. None of us have been part of this. So this is the first time. And yeah, to be honest, it was pretty exciting since yesterday. A lot of virtualization and all of these topics pretty interesting. But here today I would like to talk more upon timing, profiling, and tracing in AUTOSAR classical and adaptive platforms. So about myself, I'm Shrikant. I did my master's in automotive embedded systems in Darmstadt. Currently leading the team in adaptive platform POSIX R&D team in GLIWA. So that's my experience. I won't talk much about it. So it's been nearly 4 to 5 years now that I have been working in the POSIX domain. So that's one disclaimer at the end, that I am pretty much I can consider myself as a pretty new to the open source software development area. Agenda, I would like to shortly give a little bit about what the company is about and a bit of AUTOSAR timing parameters, and then we'll look into the timing aspects in the classical versus the adaptive platforms, and then of course we'll look into some real world scenario, and if at least 2 minutes or some time left, we will have a very quick look into the demo part. Okay. So GLIWA is there since 2003. It's a German company. We are close to 50 employees. When it started, we are more into the classical AUTOSAR part, and over the 22 years now that the GLIWA has been experts in providing the timing solutions. Of course, stack and memory analysis. As I said, it's been there for 22 years. We are into adaptive platform POSIX since 2019, so it's not too long that we are working into the POSIX world. And currently, we are supporting for timing analysis and stack memory for Linux and QNX systems. And these are the list of OEMs and the tier 1s that we are currently supporting and who are our customers. He is the one who founded the company. He was working as in ETAS before he founded this company, and then currently he is actively coaching the international automotive OEMs and tier 1s. Also recently, he also has authored a book called Embedded Software Timing. It's nothing about our company or our tool. It's more about the generic concept of embedded timing. So if somebody is interested, they can have a look into it. So it's there in 5 different languages, including Chinese, Korean, and Japanese. Okay, so coming to the embedded software timing, I think this is pretty much known to everybody. I don't have to talk much. And this is, we provide, so currently we provide the ASIL-D certified components, which can go into the car, and there are few of them who are currently running on the road with our libraries and the instrumentation library being inside the ECU. Of course, we do a lot of firefighting with most of the everyday time. We look into the overloaded systems of our customers. They see the overloaded systems, but they want to add the functionality, and they see sporadic crashes. Yeah, you just can name it, and most of them have been seen, and we have fixed it. Of course, you cannot sit in front of the tool of the timing and tracing tools and start looking into each of the tracing individually. So you got to have some automation, a way to automate it. So of course, we do also provide some kind of REST APIs with which you can automate the entire tracing and the timing validation part. To give a very short overview on the classical platform, this is how the setup looks like roughly. And from us, we provide two parts. One is the host software, which is on the left or on my right. And then on my left, there is a target software, which is kind of library that goes into the ECU. And then you have an interface. It could be anything that you could basically trace for visualization. But even if you don't have a PC or a host software to be available, you can still run in the car, do some acceleration stuff, and you can set some kind of constraint violation parameters like a threshold, and then you can go for a test ride and then come back, and then you could still see what happened if there is some violation in the constraints. Okay, so talking about the AUTOSAR and OSEC timing, so this is a typical classical platform. On my entire right on the top, you see a basic conformance class, the operating system state machines. And on the bottom, you have a little bit of extended task where you have an extra waiting state. And these are basically the timing parameters that the OEMs or the tier ones basically they look for to validate the functional part or whatever the software requirements about the timing stuff. So I won't go much into details, but these are some abbreviations, and here are some details. Of course, you can go to GLIWA.com, where all the brochures and there are some timing posters which talk about more generic stuff, and they are available for free to download and read them. Okay, and coming to the POSIX part, I mean, this on the rightmost part is a very simplified state machine of a POSIX domain, but of course, it gets more complex than what we see here. And on the right, you can see timing parameters, how they differ in the POSIX domain, where you have threads being migrated into a different course at different times, and okay. Okay, well, anyways, real-world systems looks completely different. This is one of such type where you don't want to measure only one ECU. You want to have a synchronized tracing between the two ECUs, and there could be classical platform versus classical platform with different number of cores, or it could be the adaptive platform, and then you have a classical platform where you want to again to have a synchronized tracing, and the last one is being something like this, where you have a safety MCU which basically boots up your SoC, and then you want to have a synchronized tracing to see from the boot signal to the booting of the adaptive system how the tracing looks like. Okay, and we saw that a lot of talkings on the SDVs since yesterday, and I just tried to make some relevant information here, which could be, which could make it more sensible. So here I try to give some kind of a combined synchronized tracing demonstration. So of course here what we have is an elk which is running on the road, and there is a car coming in. So the objective of this is to detect the object and then steer it so that it won't hit the object. So I think I will. Okay, so that's roughly what I explained, and this is typical steering. Yeah. So what's happening here? So the tracing verification of the event chain becomes more important rather than just measuring one ECU timing parameter. So here, the detection of an object, there's a planning goes on the another adaptive platform event, and then it calculates the required steering part, and then there is a motor math that happens, and of course, it will be sent back to the motor control. And in the end, if you see, this is the entire chain of events that you would expect to have in the final stuff that would any of the integrator or at the end, it's like end-to-end requirement specification that would come from the automotive part. And this and then you see whether this timing is met, and if not, then the end-to-end is not matching anymore. Yeah, so that's the question basically you would ask. Okay, then I'm not showing the demo because I think I'm running short of time. Basically, I had the same demo that you saw in the elk object moving stuff, but that's fine. So now coming to the part is that, of course, we are not part of AGL at the moment, and we would like to see if there is an opportunity to where we can contribute a little bit and see how we can progress. So basically, that helps our tracing capability in a virtualized systems, like where we have seen since yesterday, there is a lot of virtualization going on. Okay, so thanks. So yeah, so I just wanted to make a presentation because I don't know, like there is a lot of people working in a lot of domains. Maybe if something you feel is relevant and we can contribute something to it, if it makes sense, please come and talk to me, and then we are ready to see how we can collaborate with AGL. Thank you. Thanks a lot.